Yeah. So normally why we will go for partitioning? Sorry. Partitioning is a way in which database splits its actual data. 1 minute. Keep in mute. Just a minute. Yeah. It will split the actual data into separate tables, but still it get treated as a single table by SQL layer, right? So for example, one big table is there. In the table, you are storing 12 months data. So if you see like this, 12 months data is there. For example, this is the whole table. In the table, actually, 12 months, just 12 pieces. It's very difficult, but complete. For example, 12 months data is there. 12 months data. So now if I want to get the data from select star from table heavy, where date equal to Jan 2nd something actually, okay. In that case, what it will do, all the 12 months data, it will do the full table scan. All the 12 months data, it will do full table scanning actually, lot of time waste. Just I'm looking for January data, but it is searching almost 12 months data, full table scan. It's going for a full table scan, FTS, right? Lot of time consumption, resource consumption. To avoid this one, if there is a possible, what we are doing actually, we are dividing the 12 months data. Some people will divide it as a quarter. Some people will divide it as the every month actually. So for example, if I am dividing as a quarter, how many quarters will be there? 4 quarters, right? I can divide it like a 4 quarters. So in that case, what will happen? So every 3 months, one piece will be created. One table will be created, or else one chunk will be created. Whenever I need a data for same January one, select star from table where date equal to Jan 2nd. Instead of searching all 12 months data, only it will scan just 3 months data. It will directly point to the respective quarter. It will not go to the remaining chunks. So for me, almost 75% performance improvement is there compared to previous setup. 75%. I am excluding this much part for full table scanning, right? For example, if I go for every month, then it's very faster actually. So whenever you are going for a partitioning, one way it is good actually, okay? I can split data as a chunks. So my select operations are very fast. Read operations are very fast. But coming to write operations, performance will be little bit lag. Why little bit lag actually? For inserting data into the parent table, that parent table will decide this data related to it, just like a check constraint. It will decide this piece should go to quarter one, this piece should go to quarter two. Like that, it will decide actually. So while inserting data, little bit performance glitch will be there. But for select operation, performance will be good actually. Okay. You want to ensure that table looks up, see, whatever it is, whether select operation or update operation, delete operation. So simply, if you are using without where condition, right, no usage actually. We will call this as a partition pruning actually. Partition pruning, right? Partition pruning. So even though you have divided table as a partitions, still if you are not using where condition, in the where condition you should use partition column. Then only it will get exact whatever the chunks I need to scan, that chunks only it will scan, or else it will scan all the tables. If you are not using the partition key in the where condition, it will scan the whole database, whole table. No point of creating a partitions. Okay. By default, whenever you are using where condition with partition key column, partition pruning will be enabled. You no need to separately enable the partition pruning. Okay. So that's what actually I told actually. Any partition column, see, Normally, select update delete should include that colon in where class. Okay, in that case only you will get the benefit of partitioning. Otherwise, the storage engine does a scatter gather and queries all partition in a union. See, if you are not using where condition, in the where condition partition column you are not using, then it will think like, okay, you need full data. He is not pointing to any specific chunk. So immediately it will scan the whole data. Okay. Generally, we must add the partition key into the primary key column. Okay. Normally, whatever the key you are decided to keep it as a partition key, right? That one will be normally primary key. And one more thing, I will make it like a auto increment. Then every time I no need to make sure I'm inserting the unique value. If you give an auto increment, definitely it will go with a unique value only, right? So that is the reason. So your partition key is there, right? Your partition key will be, sorry, your primary key will be partition ID, at the same time auto increment as well. Okay, if you don't have well designed small columns for this composite primary key, it could enlarge all of your secondary indexes. Okay, if you are not designing properly, that partitioning key is there, right? If there is no auto increment, if there is no primary key, what will happen? If there is no primary key, to increase the performance, again you need to create a indexes, actually secondary indexes. So then that is again problem. Actually secondary indexes will consume more space. Okay, and one more thing, if you are going to do partitioning, you can do by range or hash partitioning. Range partitioning is there, hash partitioning is there. Okay, range is actually normally when we will use is, range is great because you have a group of known IDs in each table, and it helps actually when querying across partition IDs. See, less than, greater than, between, so and so date actually. So like that I will mention the range actually, range from 1 to 100, or else range from the creation date January 1st to April 1st. Like that I will mention a range actually. From 2 will be there in the range partitioning. Okay, again in this one actually we have a concept called horizontal partitioning and vertical partitioning. Externally it will not appear, but outside actually by default vertical partitioning only there. What it will do, vertical partitioning, your table is there, right? It will divide as a multiple tables. That's what I'm saying here. See this one. So your major table is there, sorry, your parent table. In the parent table actually, parent table, whatever the partitions you are creating, right? Each one will be contain a, each one will be treated as a separate table actually. All the child tables is there, right? Our current setup is this one only. Vertical partitioning we are going actually. Here horizontal partitioning divides table rows into multiple partitions. What they are saying actually, rows actually, for example, if 100 rows are there, what it will do, that 100 rows, quarter, right? 25 rows, 25 rows, 25 rows, like that it will split it actually. All columns defined to a table are found in each partition. So no actual table attributes are missing actually. All the partition can be addressed individually or collectively. For example, table contains whole year sale transaction. See, my table contain whole year sale transaction being partitioned horizontally into 12 distinct partitions, where each partition contains 1 month data actually. Each partition, see, 12 months data. See this one actually. Let me add it. Little bit small confusion is there actually. This one. Just a minute. So each one actually, each day, sorry, 12 months data is there, right? It will be divided like a each month data into a separate partition actually. Okay, 12 partitions. It will divide actually. Vertical partitioning, if you come, vertical partitioning divides a table into multiple tables that contain fewer columns actually, fewer columns. But here, if you see this one actually, it will contain each partition contain all rows actually. All the rows will be there, but wherever you are using the logic actually, that time it will scan that part only. Okay, like a, this is like a logical one, vertical partitioning like a physical one actually. What it will do, this physical partitioning especially, see what I can do here. another actually next year is there. Another 12 tables. Next year is there. Another 12 tables actually. So this is completely physical. Wherever you go right now, vertical partitioning only. Nowhere horizontal partitioning. This is not achievable. Okay, this is not achievable. Internally, it's actually logical, based on the logical structure actually. Every time all the rows is there. Whenever you want to select the data, that piece only will select. But here not like that. While creating itself, it will create the child tables. For example, see, child table 1 is there. Physical is there actually. Child table 1 is there. Jan 1st to Jan 31st, right? Child table 1. Second thing, child table 2. I can say actually I can access the tables. It is nothing logical. Everything physical actually. Feb 1 to Feb 28 actually. Okay, like that. Each table I have actually. And one more thing, if I want to find the size, right, completely I can able to find it. Backslash dt plus, not dt plus actually, each partition size, each partition table size we can calculate as it is occupying its own space. Okay, its own space, nothing logical actually. Okay, and one more thing, vertical partitioning, a query scan fewer data, which increases query performance actually. See, whenever I'm selecting the data, right, it will not scan whole data and it will not pick up my required piece. Only it will scan my required part only. It will give that required piece of data only. By default, right now, everywhere vertical partitioning only, no horizontal partitioning. I don't think that concept is existed also. So right now we have vertical partitioning. Coming to MySQL, in partitioning also we have few types. Okay, one is range partitioning, list partitioning, columns partitioning, hash partitioning, key partitioning. Hash and key, it has a bit relation, small relation actually. Sub partition also there. In the partition itself, again I can divide it as a sub partitions. Total, I think six, right? Six partition is there, but most of the areas we will use this one, range list partitioning. But some areas people are using hash partitioning. Hash partitioning, you no need to do anything actually. Automatically system will spread the data right across parallelly or equally it will spread the data. So that is the reason most of the people will prefer hash partitioning to reduce the overhead. Okay, so what I can do, and one more thing, what I can do, MySQL range partitioning. First I will show you range partitioning. Range already I told, right, from one starting point to ending point, like that actually. Some certain range, January to March, or else April to July, like that actually. Certain range, or else ranks from 1 to 100, 100 to 200, like that I can do actually. See, we can define values, less than operator, greater than operator, these kind of things. Okay, I'll do one thing. I will create a one table. See, very simple actually. Create table, one table actually. Sales, this one, sales master data. I'm storing bill number, bill date. Okay, bill date and customer code, amount up to this point. Okay, after that what I done here, partition by range, partition by range actually. So based on the timestamp, see, bill date is there right here, my bill date column. In the bill date column, I am creating the, on top of build date, I'm going to use this as a partition key. Which partition? Range partition by, I no need to give Unix timestamp, externally converting actually. Directly I can use build date colon also. Build date colon is my partition key. So this is a timestamp, right? So range, see, partition P0 values less than, for example 2013 sample data. I have this one only. Okay, 2013 less than, I mentioned less than, see, less than 2013 April 1st, it will go to P0. Here less than July 1st, it will go to P1. Less than, that means what they given, each quarter, right? Less than April 1st means Jan 1st to March 31st, right? Quarter 1. This one April 1st to June 30, quarter 2. This is quarter 3, July 1st to September 30. Okay, so like four quarters actually. Let me create a table. I'll do one thing. MySQL, so databases, create database. We'll do one thing anyway, partitioning, right? Partition something. PIONS partitions, okay. Let it be. Use partitions. PIONS, okay. Partitions. So tables. I don't think I have tables here. None of the tables are there, okay. So let me create one table. So I have created one table actually, okay. After creating the table, I will insert the data. See, some data I will insert it internally. We are not doing anything. Simply we are inserting data, right? If you insert actually, see, data inserted, select star from sales master. This one actually I have the data from parent table. We can able to access everything actually normally. But my intention is actually, see, after selecting the data, here is the partition status. I want to find it actually. Where can I get the partition table information? See, select partition name, number of rows, table rows actually from information schema dot partitions. In information schema, partitions table is there, where table name equal to my table name I'm giving actually, okay. So if I go with this, see, do this one actually. How many partitions created here? P0, P1, P2, P3, right? Like this. P0, P1, P2, P3. These rows are there. Number of rows are there actually. So here, one small change actually. Yeah. Total how many rows? This one, 1 minute. Wait a minute. Just wait a minute. Let me give this one. Original value I will give. Mommy, chudu. Mommy. Mommy. Mommy, chudu. Wait. Yeah. Number of table rows in the partition. For partition table, the row count given in the table rows column is only estimated value used in SQL optimization. Okay. Let it be estimated rows only displaying, but my case, 1 minute. Yeah. See, if you see this one actually, first one, Jan 2nd, Jan 25, February, March, right? Almost how many records are there in P0? P0. So you need to do one thing actually. And I need current value, okay, not starting value. If I need a current value, how can I do that? And the table rows not equal to 0, okay. So if you see this one, P1 contains 3 rows, P2 contains 2 rows, P0 contains 4 rows, P1 3 rows was duplicate also coming actually. P2 contains 2 rows, okay. Let it be. What I will do, I will select from one table, okay. Select show tables. So tables, if you see, sales must only there, right? So I will do one thing, select star from P0. Wait. So it is giving exact number of rows actually. Let me get the table status. All the child tables will be printed. See, show table, 1 minute. My table, right? So table status, it will display all the tables actually. Whenever you are entering so table status, what are the tables are there? Each and every table status it will display. In my case, actually, it is clearly saying this is a partition table. Whenever you came to know that so and so table is a partition table, I can get it actually definition, right? So create table. This one actually, so create table. Table must is there, right? Sales must /z. Okay, if you see this one here clearly mentioned actually each partition how it's defined. This is actually internally we are converting, right? Unix timestamp. So that's the reason it's printing like a number actually, okay. So each table with the partitions it is displaying, okay. And one more thing actually, so that one range partitioning also at the same time, same as this one actually date, I can mention the just number also, okay. See, one more table I am creating, sorry. Yeah, this is previous one actually timestamp. This one just value less than 3, less than 7, less than 9, like that. So if I'm inserting values into the table, so this is range partitioning. So see this one, okay? Total 10 rows I have inserted. If I go with this one, wait a minute. Information schema partitions, right? So here I can go like this. My table name is TRB1. TRB1 actually, see. Each partition, each row actually, each one, total 4, 2. Yeah, total 10 records, right? I have inserted 10 records. This one, each table wise, each partition wise, how many rows are there? It's displayed. And one more thing, if you go to the explain, normally straightforward explain I am going, what will happen? Explain select star from TRB1. If you see, total how many tables it is scanning? Total 3 table, 4 partitions, right? Partition 0, partition 1, partition 2, partition 3. All are scanning actually. All the 4 are scanning. Why? You are not using any where condition, right? That is the reason it is not going for a partition pruning. If there is no partition pruning, even though you have you created a partitioning, no use actually. Okay. If partition pruning is working, then only I can treat like a it is working as expected. Huh? So I can use where condition, then only it will work actually. So see, normally what I can do now, like this, in the above where you can partition the table based on the sales amount also. In my table, how many columns I created? If you see, scroll up, little bit scroll up actually. This one, yeah, ID is there, name is there. Just a minute. Purchase date is there, okay? So if you want not only ID, if you want, you can use the purchase date is there, right? That rate also based on the date column also, you can build the partitioning actually, okay? That is one example. And one more thing, already, for example, already partitioning is there. If you want to drop that partition, you can drop it actually. See, our previous table is there, right? Alter table sales must truncate partition P0. See, this one I have already. What is that? Sales underscore must, right? Sale underscore master, sales underscore master. Yeah. So if I want to drop, actually, I can drop the partition. For example, completely truncating partition P0. P0 records I'm completely truncating actually. So now if you see, so P0 gone, right? Earlier P0 is there. Why? As it is having the data, that is the reason P0 displaying, partition is displaying like a number of records. Whenever I'm dropping, that number of records gone from the only that single partition. So if required specific partition also, you can, from specific partition also, you can remove the records actually, okay? After removal, see only 5 records only there, right? Almost how many rows truncated? If you see this one, complete table I truncated, right? Earlier in my P0, 4 records are there. Okay, like that you can drop it actually. And one more thing actually, see, after dropping the partition, I given this one, right? Status, P0 gone actually. That one I given. Now, if I'm coming to the list partitioning, range means less than, greater than, this kind of thing. List not like that. I will pass one value. For example, I have 3 values. A, B, C. Okay, A, B, C is there. 100 students are there. Not 100, 120 students are there. These 120 students, I want to divide them as a 3 sessions, ABC. Okay. So now I have created 120 seats. Each seat contain A, B, C like that actually. Okay. 40 A's, 40 B's, 40 C's. I will tell them, hey, whoever getting A, go to the A section. Whoever getting B, go to the B section like that. So here also I will create the table. I will create the partitions based on the specific input. In which table they are inserting specific value, the data will go to respective partition. See, for example, actually, see this one, values in. I am creating the table. See, create table sales MS2, bill number, bill date, agent code, okay, amount ID. Partition by list, earlier range, right? Now I am using partition by list based on the agent code. Agent code is the integer actually. See, agent code integer. So based on this, I am creating the partitioning. I am clearly saying, if you are a partition A, when data will go to partition A, If anyone inserting agent code 1, 2, 3, it will go to partition A. If anyone inserting 4, 5, 6 to the agent code, it will go to partition B table. Okay, like that actually. 7, 8, 9, 10, 11. If anyone inserting as a agent code, it will insert to the partition C table. See, we'll do one thing. I have created a table, right? So create table slash G. Okay, slash Z. Here partitions clearly mentioned actually. Value 1, 2, 3 automatically partition A. Value 4, 5, 6 it will go to partition B. These values go to partition C. What is this value? If anyone inserting data into sales master table, okay, during that, if agent code value falling in this criteria, then it will split the data. If it is not splitting, it will throw error. I will show you that one as well. Let me get the insert one. So this one insert example I will show you, and only you will come to know. Let me take one insert statement. I might have. Okay, let it be. I don't have handy, but anyway, I will do that. No problem. How many columns? Select star from sales must do, right? If you see array, let me get the columns. Okay, 4 columns, right? We'll do one thing. Insert into sales must, right? Values bill number 1, for example. Yeah, it is nothing is auto incremental, right? Bill number 1. Now bill date is there actually. Bill date while inserting data dynamically I'll use it. Manual I will not insert that one actually. Manual insert a problem again. I can do timestamp also. Wait a minute. Directly I will insert timestamp. We'll see. We'll give a try. Agent code, for example, 1 amount to 1000 rupees. Okay. If I'm inserting like this, wait a minute. Timestamp. Wait, we can insert actually. That one also we can insert. Dynamic timestamp insert in MySQL column. Okay. Don't use this one current timestamp. By PostgreSQL simply we will use now, right? Now we will use it, but here small change is there. That's what I'm looking actually. I cannot use like this. Let me give a try. Okay, perfect. Select star from sales must actually. Okay, so if you see this one, current timestamp inserted, right? Perfect. Like that actually. Let me insert another 2, 3 records actually. Just number 2 agent ID I will give 1 only. This one 2 only. Okay. Now let me make actually agent ID 2. This one 3. For example, agent ID 8. Sorry, 9. I will make it as a 4. Okay. Now I'll do one thing. 15 agent ID making 15. This value I'm making as a 5. So what it is saying actually, see, and someone tell me whenever I'm inserting agent ID 15, why it's throwing error? Why it's throwing error? Partition not there, right?
Yes.
Up to what level we given the partition? If you see, up to this part only you given partition, right? What is that actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Until 11 only, okay. Other than 11, if you are trying to insert any value for partition key column, automatically table has no partition value. That error will be throwing, right? Perfect. Let it be. So up to now, I 1, 2, 3, yeah, 1 to 9 I inserted, right? So that means my data in PC and PA only, right? Let me insert one more value. This one I'll go with a second partition. Safe side. Second partition 5, right? 5. This one value 6. Okay. Total 3 partitions. Now I have table. This one actually. 3 partitions. I have the data ABC. I have the records. How can I get it? Same thing, right? We will get the data from select star from select star from information schema dot partitions. Okay. use use information schema. So tables, metadata tables. Here I have the partitions. Yep. Okay. Use my partition database. I will do one thing. Select star from information schema dot. I can use the partitions list actually. Lot of partitions are there. So, but I don't need all the things. What I will do, main part only I will take it. First, table underscore name, right? Just a minute. So, if you don't want to take this much risk, simply you just do the limit one. Limit one is enough, right? Everything will be printed. Table name is there and partition name. Table name or partition name, right? Yeah. Table underscore name, comma, partition underscore name. Partition TITION, right? Partition TION. Partition name. Okay. Just wait a minute. Limit one. Okay. Wait. So partition name is there, right? Okay. Now I will do actually table rows. I want table rows. Table underscore rows. Each partition has how many rows, right? That one I want actually. Now I can make it partitions where condition. Use the where condition. Where table underscore name equal to, I will give the our table name. Okay, what is our table name? Sales master. Sales master only. Yeah, just now I done. Yeah, sales master. So see this one actually. Partition A, partition B, right? You can make and one more thing. Table rows not equal to 0. Okay, 0. That means see first A has 3 rows, B has 1 row, and C has this one, right? So this is based on we have taken based on the list, right? List. Why the type of value you are inserting based on that it's splitting the partitions. Huh? Now normally at the same time you can use date and date time columns is in list partitioning as well. Okay, not only values. Normally list means everyone will think like a only passing values, but if you want actually you can use this one also. What is that actually? Sorry, this is range partitioning. List also there. List also if you want specific date in so and so value you can give it actually. This one what I have given same example, range one only I given example again. Okay. So now you saw that range partitioning date, you saw that list partitioning based on insert value. Now hash partitioning is there. MySQL hash partitioning. MySQL hash partition is used to distribute data among a predefined number of partitions on a column value or expression based on a column value. See, whatever the value you are inserting, right? Already predefined partitions. I will create while creating the table itself. I will say, hey, for me create 4 partitions, or else for me create 8 partitions. So just you are mentioning the name, you are giving the specific column name based on which column data it need to split. You need to mention that's it. See, this is done by using partition by hash. This is the expression partition by hash class. Okay, we will add this statement to create table statement. In partition number class, number is positive integer represents the number of partition tables. See, I mentioned here, right? Number of partition tables will be created. How can I create? We'll see. I am creating one student table. Student ID is there, class is there, name is there, date of admission is there, right? Partition by hash student ID. Okay, whatever the data you are inserting to student ID, based on that by default it will create 4 partitions. It will split the data. We'll see how it will split the data. We'll see that. For example, I created a table, right? So create table statement, create table student, right? /z. Okay, if you see this actually it will, by default, it is going to create a 4 partitions. I'll do one thing. Let me check the partition part. This one, right? What is my table name? I don't want, right now I have not inserted any data, right? So what I will use, my table name student. Let me check any partition tables are creating actually, okay? If you go with the student table, what it is doing actually by default, how many partitions creating? 4 partitioning, P0 to P3, right? Total 4 partitioning creating actually. So this is 2 times printing, something I need to check actually. Normally what we will do, distinct, I will mention a distinct partition name, okay? I will not mention the bigger one. See how I'll do that. Select distinct, I can mention like this. Distinct, if you want a very clear cut. Distinct partition name, comma, table rows from student so thing, right? Student one. If you see like this, it will give you the original number actually, okay? So I have not mentioned, I have not created any partitions. But as I mentioned partition keyword, it's created a 4 partition. Now you are inserting data, try to insert data. It will parallelly, based on the value, it will split it actually. Where is the table one? Student ID, right? We'll do one thing, insert into student values, student table, where it is. Student table values, okay. First column, what is that? Student ID 1, comma, class, which data type? Varchar, right? Varchar 8th class, for example, okay. 8th class, for example, name Rambabu, okay. Comma, what is that? Date of admission they are giving, right? Here actually data directly we need to pass the timestamp, okay. They are not given any default column. If they give default column, you can use current timestamp, right? If they are not giving, simply you can use actually 2022 year, given actually month now this one, right? August 15th actually, okay. Like that you can insert the data. Inserted one record. Now to ninth class. 10th class also one guy is there, but it is based on the class ID, right? See, 4 just few values I'm inserting, that's it. Other than that, nothing. What happened? That are too long for 10th class. Why too long? We are carried, right? 8 more than 8 characters it will not allow. 10th class, okay. 10th class, perfect. Like that. 6 Sam, okay. Like that. So I have inserted some data, right? Let me get this tables data now. We'll see. So if you see this one actually, and table rows not equal to 0, original value it will print not equal to 0. If you see, I have not mentioned anywhere, right? In the while creating partitioning itself, I have not designed. I have not defined any values, but here automatically it will took the values and it will inserted actually. Okay, each table it has inserted. It will split it based on the inserting value, hashing algorithm. Okay, so better. This is also one good way. Properly it will distribute the data. You no need to worry. Okay, whatever the number of records you are inserting based on partition key column, it will split it actually. Okay, equally it will split it. And one more thing actually, if you go with a hashing partition, right? Don't think only integers. If you want, you can give any year also, okay? Year column also it will do. Like that you can do. See, date of admission is there. Based on year column also, it can split the data across partitions. Only thing you have to define. For example, 12 months data you are storing, give 12. So what it will do? It will split across 12 months, 12 tables, 12 partitions, okay? Other than this, we have actually MySQL key partitioning as well. MySQL key partition is a special form of hash partition. Right now you have hash partitioning, right? So for that hash partitioning only, this key partition is just a special form actually, where the hashing function for key partitioning is supplied by the MySQL server. The server employs its own internal hashing function, which is based on the same algorithm. See, even though I am giving hash actually, see, instead of hashing actually, I am saying key, okay? Key distribution actually. Partition key is there internally. Internally, it will create the partition key. It will split, same as this one. Up to you. Either you will use hash or else partition by key. Partition by key. You will use this one. Up to you. Both are working same. Automatically it will split your data same. Same fashion actually. Okay. And one more thing. If there is no primary key, but there is a unique key in the table, then unique key used for the partitioning key. Normally, whenever you are creating a table, make sure this one, see, whenever there is a table, if you are creating table based on partition by key, right? So you need to create mandatory primary key. This is one way. See, I will do one thing. So primary key is there, but this time I will do one more thing. Table 2 I am going actually. Table 2, no primary key, at least unique key should be there. No primary key. That's what I mentioned actually. So what I will do, I will not give primary key, I will not give unique key. Okay. Then we'll see. Not null, I'm giving actually. What they are saying actually. Field in the list of fields of partition function not found in the table. Why? You are already mentioned, hey, distribute the data based on the key. Which key? Primary key. If no primary key, at least create a unique key. Okay. So try to do unique actually. So this one, this kind of things actually interview or certification will come actually. Okay. So unique key I created. See, whenever I'm creating unique, right? Immediately it's creating. But if there is no unique key, if there is no primary key, partition by key, partition by key is there, right? It is not possible for your information actually. See, that one I will mention here. So this is the note. Okay, to do the key partitioning. Next one, MySQL sub partitioning actually. Just like a nested. Sub-partitioning is a method to divide each partition further in a partition table. Normally, they given like this. See, what we done, creating table, okay? One table creating, partition by range. Partition by range based on the sale date. This one sub-partition by has 2 days actually, okay? See, sub-partition by has 2 days. So, what I am saying, for each partition, create again 4 sub-partition. First one is based on the year range actually. Second thing actually, in the year, each year again it will split it as a 4 sub partition, like a quarter actually. Okay. So this is the way I can create a sub partition. First it will categorize as a this one. What is that? It will create the 4 partitions based on the year. Later, while inserting the data, it will go into the sub partitions. We'll do one thing. Let me get the table. Partitions, number of partitions is there, right? I have my select one. So table 10. So even the partitioning is there, still we can build the sub partitions. Right now nothing inserted, right? Table this one is there actually. P0, P1, P2, P3 is there. Again, we will divide as a sub partition. See, the table has 4 range partitions, right? What are the 4 range? 1990 less than 1990, less than 2000, less than 2010. Okay. Remaining all until max value, remaining all will go to partition 3. Okay. So in this case, each of this partition P0, P1, P2, P3 is a valid into, again, each table divided into 4 partitions. Therefore, the entire table is divided into 4 into 4, right? 4 partitions. Each partition will divide it into again 4 sub partitions. 4 into 4 total 16 partitions actually. Okay. It will divide as a 16 partitions. 1 minute. So let me get that one. So see, total how many partitions? This one. Anyway, 16, right? 16, first one duplicate. One set duplicate will be there. So by 2, right? So if I start inserting the data, then it will display only 16 partitions with actual data. Okay. Like that, I can able to print it. So after that, create table in C. One more thing I done. Create table sales must actually build date is there. Already one table is there. Okay. One table is there. That table, if you want to add partitioning, you can do the partitioning. That is possible. Okay. So this table is there. Sales must table is there, right? Already one table is there, it seems. So tables drop sale must, right? So this one array, what happened? Drop table. top table sale underscore master, right? Like this actually. Okay, done. Let me create the table. I create the table, but no partitioning. Later I came to know that okay, I need the part. I need to divide this table. Yes, you can divide by doing the alter table name, partition by hash, 6 partitions I need to create actually. Okay, so easily you can do. See now, create. So create table. So create table. What is that? Sale must, right? Sale must slash z. If you see, simply it's creating the table. For partition is there, right? Partition by hash, partition 6 actually. Okay, like that existing table also you can create the partitioning. Okay, if you remember during the maintenance, I told actually on top of partitioning tables we can perform maintenance. How we can perform? See this one. Table maintenance of partition tables can be accomplished using the statement. Normally what we will use? Check table, optimize table, analyze table, repair table. These options we will use, right? So same all the options we can use for partition tables as well. How to do that? You see. For example, alter table rebuild. See, rebuilding the partition. How to rebuild? This has the same effect as dropping all records stored in the partition, then reinserting them, right? What is rebuilding actually? Dropping and recreating only. See, alter table, you don't give parent table, only parent table. Okay, rebuild parent table, no data, right? Child table only has the data. Alter table T1, rebuild partition P0, P1. If you have any table like a T1, for example, my case, this table only will do. Alter table, sale must, right? Sale must rebuild partition. I will mention what are those actually 6 partitions, right? This one P0 comma P1 comma P2 P3 P4 P5, total 6 partitions, right? Like that I can rebuild it actually. Okay, whenever I have a table, so I can do that, like I can do like that. See this one, this is the parent table. So let me do the rebuilding. So explicitly you need to mention, each partition. Okay, so like this. For example, if you want to optimize the table, that also same thing. See, if you deleted a large number of rows from a partition, when you will do the optimize operation for defragmentation, to remove this one, to redistribute the data again, to avoid the fragmentation issue, we will do the optimize, right? Alter table, my table is there, right? Anyway, sale must table is there. Alter table, table name, optimize partition. I will give all the partitions actually. Okay, so this one P0 P1 something actually. Okay, this one you can do like this. So everything, that's what I told that time, we will use the alter table actually. See what it is saying. Normally table does not support, right? Optimize InnoDB tables will not support, right? What we can do? Simply drop and recreate, or else just alter table name, force, right? Like that also we can do that. Okay, alter table name, force. I think we can use like this, alter table name, force. I don't think this one will work for this. Okay, this one just dropping and recreate each partition. Force will not work. Same. So see, analyze partition also same thing. Repair table also same thing. Alter table one. Primary table nothing actually. Sub partition only we will do that one, right? And one more important thing, partition pruning I told actually. The optimization known as a partition pruning. Okay, optimization for any partition table. If you want to get a better performance, you need to follow the partition pruning actually. Okay, what is partition pruning? Exact part. I have created 4 quarters. If I needed data from January, it should scan only first quarter, January, February, March data only, right? Then only I can say my partitions are well optimized. I am getting the data from exact chunk. Okay, so for that, how can I achieve that one actually? See, very simple. I will create one table, for example. Okay, I will create one table T1, and this is actually range partitioning only. Okay, so see this one table creating, table name T1. Now if I do condition select so and so columns. Actually, I'm giving where field actually region code I'm using. Why region code using? Region code is part of region code is my partition key, right? See, my partition column is region code. So that's what in where condition you need to use the partition column. Now no data is there. Even though no data is there, let me check explain plan for that. Only how many tables it is scanning, it will display. See, I have how many partitions? I have 4 partitions right here. But still it is scanning only P1 and P2. Why? Here I mentioned one between 125 and 130. Where it is 125 and 130, it is between actually partition 1 and partition 2, right? Okay. For example, if I mention like this 190, if I do like this, see this one actually 190, sorry, 200, I'll make it as 200. In that case, 3 partitions will come. P1, P2, P3, right? So like this it will come. For example, if I'm not using where condition, so what will happen? From T1, right? If you see, it is blindly scanning all the 4 partitions. Whenever you are not using your partition key colon in the where condition, no point of creating a partition. So there will be no partition pruning will happen actually. Partition pruning, okay? Remember this word actually, okay? Like that, I'll make it my partition key in a where condition, okay? And one more thing actually, reorganize also possible. Okay, reorganize. For example, already one you have a table with partitioning approach. After that, by default earlier you decided, hey, less than 5 go to P0, less than 10 go to P1, less than 15 go to P2, like that actually you decided. Later you think that no, I want to change the values. Then you can make a change actually. See, for example, this one employee subtable is there. I think I don't have that one actually. Maybe I missed it. Employees underscore sub alter table, right? I want to alter the table. Alter table. Okay. Employee sub. And one more thing, reorganize partition. Wherever partition three is there, right? Partition three condition not correct. Actually, I missed it. Somehow I missed it. But for you, for your information, maybe I would say in WhatsApp, don't worry. But you can already existing limit is there, right? You can modify anytime. That means I can do reorganize one partition data, I can move it into another partition, okay, with a reorganize partition option. This option also there actually. The bad thing actually, for example, see, I will do one thing. Right now we have lot of tables, right? So tables, each table we have more data. Select star from sale master is there, right? Sale master, no, master 2. Yeah, this table has data, right? This table has data. Let me take the dump actually. MySQL dump, MySQL dump hyphen D, which database? Sorry, wait a minute. Yeah, partitions actually. MySQL dump hyphen, no. Hyphen T, hyphen U root, 1 minute. Hyphen P, I will give the password. 1, 2, 3, hyphen T, hyphen T, what is that? Sale underscore master 2, right? Master 2 and hyphen P given, right? Already database name. You give the database name, partitions. So sales master2.sql actually. Master2.sql. Okay, I'm giving the dump file name. Why? Wait a minute. Anyone remember MySQL dump command? Hyphen P database name. Okay. I think everyone forgot this one. What is the unknown database? Sales master, right? Wait a minute. So my table is different, right? Sorry. Table is this one. Hyphen T. Partitions -t sales master. Just a minute. What is the errors? Sale master.sql. Okay, my dump completed. But if you observe one thing, actually, what it is getting, little bit scroll up. A little bit scroll up. Actually, where is the definition? Table definition. I need to create table one, right? Dumping, okay, but I should get create one, right? Create statement.
You got alter on.
No, only data only I'm getting. Here I'm getting only data, right? Not structure actually. No create statement, nowhere create statement. Wait a minute. Ayyo. Completely. Dump command forget. Very comedy. MySQL dump. Where we kept this one.
I have dump command.
Ping me once. Table one.
Yeah, I'd give it to you.
Thank you. No. Table. I want table. Only one table. This is database. That is database, right?
Okay, table. I'll also I'm paying it to you.
Yeah, ping me.
Share.
Yeah, thank you. Okay. So this one, two, three. Okay. My database name is actually partition one. This is the database name. Table is sales master. Right? Yeah. This is the table. Okay. Okay. So perfect. First it is dropping the primary table, then it's creating the table with a sales must actually see. Then once creating the partitions, later it's inserting data into parent table, right? So automatically your partitions will be comes as it is actually. Okay. So you no need to worry about like PostgreSQL for partition table, each table we are taking a separate, right? But here MySQL dump actually, you no need to consider, no need to use separate commands to take partition backup. Okay, partitions backup as it is already contains the structure and data insertion like this actually. Okay, same command you can make it for the taking backup actually. Okay, so like this. So this is the partitioning concept. Especially for select performance only, we will go with the partitions instead of using bigger table, 1 TB table kind of thing. Better go with the partitioning actually. Or else, if you have a select very important for you select operation performance, in that case you can go with even though 5 GB 10 GB table also you can split like a partitions, no problem. Select if performance is matter, select operation performance is matter. Insert also matters, don't go with a partition. Okay, insert little bit slow actually. So all the 5 partitioning is there, but outside mostly the range partitioning, list partitioning, to avoid the headache, simply going with a hash partitioning as well. Okay. So anyone has any questions on this part?
Frankly saying, Ram, like there are a lot of topics we need to be practice for this one. Otherwise, we won't get.
No. Normally, we will not create, for your information, we will not create partition tables. This is
Okay.
pure development concept, right? They
Okay.
will design.
If in our environment, if you want to go for maintenance activities, what should we have to be propose? Like if you're going from next month or or is a product based company, so there's going to be a peak season is there. So I want to give some maintenance activities for them to be done from site. So there is any possibilities there, so we can propose them.
You can check actually. When was the last update? This one analyze date. What is the defragmentation size? Defragmentation size already how to find a given, right? We have only two things mainly. One is analyze, one is optimize. Remaining thing repair table only if any error is there, then only repair table. That is worst case only. Mainly analyze and this one only optimize only. For that
Okay.
both I given queries already during maintenance operations.
Okay.
So we'll do one thing. Tomorrow I will cover actually this one. This one Percona tools actually. Percona given some tools for little bit optimization, little bit enhancement, especially this one actually PTOSC online schema change. Percona online schema change. Whether alter table, adding column, dropping column, okay, adding, dropping, creating index, dropping index, any alter operations for the table, normally lock will apply, right? So no other operations can be performed on the respective table, but these guys given one more extra thing actually, Percona people, that is we will call it as a Percona online schema change, OSC, PTO. Percona means PT actually, PTOSC, online schema change, we will call it as, okay? What it will do, it will create a new empty table, then it will copy all your data from the original table to backup table, then it will perform actually, so it will perform operation on the new table, backup table, whatever the alter statement you're doing, right? It will perform on the new table. So there might be chances, right? Some people will insert the data on the original table. So what are the changes happening? Again, trigger will be there. The trigger will, end of the day, the trigger will push all the modifications to the new table. Once modification done, immediately it will do the swapping. What the swapping actually, backup table will be renamed as a original table. Original table will be renamed as a backup table. Then before original table, right? Previous original table. It will be dropped. For users, no locking, nothing. Very minimal locking. Only during swapping only, little bit, milliseconds conflict will be there. Other than that, no impact. That is PTOSC. In addition to that, few other things, 3 to 4 things I will cover actually. Tomorrow we'll see that. Okay. Yeah, for today I'll
So
wind up.
same like PG repack, right, Ram? Same like PG repack in
PG rep.
Postgres.
But PG repack good for vacuum full.
Yes.
Vacuum full. But
Yes.
this is for alter as well.
Okay.
All alter statements. PG repack not suitable for alter operations. It's only for
Yes,
vacuum
yes.
full. Correct, right? Yeah.
Ram, can we